continue with first principles. So this is our second lesson on first principles. And the first thing that I want to show you is that you don't always get your function with a function named fx. That can change. You can sometimes get one with mx or px or kx or whatever. And then you must change your notation in the formula. Otherwise, it's minus 1. So if you use fx, it's the first derivative of f. If I give it to you as mx, it's the first derivative of m. Here in the formula, we have f of x plus h. So now we're going to have m of x plus h. Thank you. Here we have fx, so now we're going to have mx over h. So don't let me catch you out with this. You will lose a mark for notation. Our first example, 8, is kx. Kx is 1 over x. That's my function. Now remember from Monday's lesson, you first have to do some homework. We need to get k of x plus h. So in all the places where I had an x in my function, I now substitute that x with x plus h. Once you have done this, did everybody sign both? So now I can substitute. K of x plus h is 1 over x plus h. And k of x is 1 over x. If you minus that, it's a fraction minus a fraction. Grade 4 work. The denominators are not the same, so now we have to get the LCM. And the LCM will be x plus h times x. Okay, now I put it on the LCM. The first term doesn't have an x, so times the x with the 1. The second term doesn't have the bracket x plus h in the denominator, so I multiply the numerator with x plus h. But remember, after a minus, you must put brackets, because I have to multiply this minus into the brackets. Right. When you have done that, you get x minus x, that's 0. 0 minus h is minus h. Now this looks complicated, so you can rewrite it as the numerator divide by h. Then we go back to grade 4. When you divide with fractions, the divide becomes a multiply, and this h, you get the reciprocal. Now you can cancel out the h's. And then you are left with minus 1 over x times x plus h. Now we look at the denominator to see if we can substitute h as 0. Can I? Yes, I won't get an error. So it becomes x times x plus 0. And that will be minus 1 over x squared. What did I actually work out here? Yes?
You have to simplify everything if it's not substituted.
Do you have to what?
Simplify it.
Yes. You simplify as far as you can, and then you substitute. Yeah. What did I actually do here? I got the gradient of that function, and it's minus 1 over x squared at a specific point. Right. Let's look at another example. They can give you the x value. If they don't give you the x value, you stop there. But they can give you at point 3. Then you substitute 3. Yeah. P x is 5. Now if you draw that straight line, it will look like this. And we know that the gradient of a line parallel to the x-axis is 0. Can you remember that from last year? Good. Now they ask us, get the gradient of this function, but use first principles. So, for first principles, we need the formula, and we know ahead of time what the answer will be. It must be 0. So let's see if we get 0. We have to do a little bit of homework. P of x is 5, and P of x plus h is also 5. There is no x here. So if there's no x, you just rewrite the function for p x of x plus h. Now we're going to substitute these values from the formula into our sum. P of x plus h is 5 minus P of x is 5. 5 minus 5 is 0 over h. First simplify. What is 0 divided by h? 0. So it will be the limit where h tends to 0 of 0. In this case, we don't have an h, so we don't have to substitute anything. So if the limit of h tends to 0 of 0, what will the answer be? 0. And there we got our gradient. What do you mean h tends to 0? This notation means if h goes near 0, what will my answer be? Okay, there is no 0 here. Oh, no h here. So it doesn't matter if h goes to 0, the answer will be 0. Okay, what it actually means is, if we have a function like that, and we have to get the gradient between 2 points, we said this one is x, and let's say there's a distance of h, then this point will be x plus h. And this y value will be f of x, and this y value will be f of x plus h. So, if h tends to 0, that means if I make this distance 0, I go nearer and nearer and nearer to 0. So I actually bring that point as near as I can to this point, then h tends to 0. So that's what this is. That was example 2. Your homework for tomorrow, that's the last example. is exercise 3, page 11, number 6 to 10. Okay, don't start with your homework now. I want to mark last Friday's and Monday's homework. Did we finish marking Friday's homework? No. Not yet. The limits.